Here's what was given to me. On the left, the instructions are to use the series expansion for cosh to evaluate. Now, we're going to do this eventually on a TI-84, but I wanted to show you what's happening here. In red, you have something that's not a polynomial. Here we have cosh. And in blue, then we're building out a polynomial so that it's close enough so that we can evaluate at a particular value. In our instructions, we're supposed to evaluate cosh at 1.5, but not using actual cosh, using a polynomial that's close enough. So that's what we're doing. I'm going to do it in a TI-84, but I want you to see the picture first. We're going to use lists, which you can find in the stat button right here, and then enter. Now, this may be unfamiliar to you if you haven't taken a stats class, but this is pretty much a spreadsheet. We need to evaluate when n is 0 through 4. That's the example that was given. But remember that it's 2n that we need to use. So when n is 0, 2n is 0. When n is 1, 2n is 2. When n is 2, 2n is 4. When n is 3, 2n is 6. When n is 4, 2n is 8. Now we're going to go over here. It's going to default, when I go to the right, it's going to default to a cell. We don't want the cell, we want the name. So we're going to go up to L2, and we're going to tell it what to evaluate for each of these. So since we're supposed to be evaluating at 1.5, I'm going to say 1.5 raised to, the power that I want is in L1, so I'm going to hit second and 1 in order to get L1. Go on to the right to get out of that field, divided by, and I need a thing in L1 again, factorial. So second and 1. To get factorial, I'm going to go math, I'm going to go back to probability, and then number 4. I hit enter. I have all these things right here. And what I need to do is take a sum of everything that is in L2. So second quit. The way you get to a sum is going to be inside of list, which is blue above stat. So I'm going to hit the blue button second and then stat. When I do that, I'm going to go over to math, and it's number 5. And the sum that I need to take is of L2, so second L2. So that sum word right there is the same as the sigma, and the L2 is all the stuff I'm supposed to be adding up. And that gives us something that is an approximation of cosh of 1.5. Another fun thing you can do is if you need the individual pieces and fractions, then I can say L2 and say math, enter, enter, and it will give me the fraction bits of L2 as long as it's reasonable. So the first 4 of them are nice and pretty and clean, and after that one it just says as times 10 to the negative 4. All right, now that you have the calculator skill, let's go back and talk about what it means for a second. I have set f of x as the actual cosh of x, and g of x is the series expansion. And I'm giving it only one term, and then I will go up to 4 terms. And here's what I want to show you. This is what we're going for. This is what cosh of 1.5 is. And right here is what our expansion gives us up to a certain point. So with only one term, 1. You see how we have no precision. But 1, oh, that's much closer. You see how it jumped? It got a lot closer. Here, that's much closer. So every time I'm adding another little tidbit, I'm adding a fraction, or I'm adding something that's just smaller than what I just added before. And so what it's doing is it's fine-tuning the expansion to be as close to this not polynomial, as close to this cosh as possible. So, but you see, I only have precision for, for a single decimal place. And now let's go again. Okay, look, my precision's getting better. Precision's getting better right here. And once I go this far, let's see, pretty good. So 1, 2, 3, 4 decimal place precision. If I round to 4 decimal places, then it's close enough. Visually, I can't see the difference anymore. If we were to zoom in, we could probably find a little bit of difference, but my goodness, I had to zoom in really, really far to see it. So it gets close enough as the blue one gets close to the red one. That's the point. If you're wondering, how do you know it's 4 decimal places if your professor did not already give you the information go this far, then that's an excellent question. So as you're moving along, you see how we get more and more precision. So this is as far as you were instructed to go. We just talked about how 3, 5, 2, and then this would round to 4. And then, but this is when I already know, this is when I'm evaluating cosh because I can, and I'm comparing it to the answer that I already know. What if you don't already know that? Then you have to go at least one more space, and then the point is that these decimals don't change anymore. So as soon as the 4 decimal places, because you were assigned 4 decimal places, as soon as the 4th decimal place is not changing anymore, then you know, okay, well, I've gotten enough precision. You can keep on going with more and more precision, but you know, you were assigned 4 decimal places, and then this gets you to 3, 5, 2, 4. And if you try to go one more, you're still at 3, 5, 2, 4, and that's when you know that you're done, if you don't already know with what precision you're working towards. The penultimate skill I want to show you, I don't think it's a super useful one, but if you go to catalog, which is second 0, and then hit this button for C, then you can go down and you can find your cosh right there. Cosh of 1.5 is that thing. There is a cosh in there. It's kind of hard to find. We kind of care. We can kind of play with that a little bit. We can make it easier to find, but that's where to find it by default. And the very last thing that I want to impress upon you is that this really came from a Taylor series, and specifically a Maclaurin series, because it's cosh of x, not cosh of x plus or minus anything. So that's coming from right here. I'm being lazy, but you have to determine the derivatives, a bunch of derivatives. Here's the function, here's the first derivative, the second derivative, etc., etc., etc. And because it's a Maclaurin series, you take all of those answers, you evaluate all of those at 0. And for cosh, you get 1, and for sinh, you get 0. And that will help us. We plug this business in to figure out, whoops, that thing. Use the numbers that we get from here. And then stuff with evenness gets a 1, and stuff where you have odds is going to get a 0. And so all of your even ones get to stay, and all of your odd ones have to go away. And then you end up with this lovely thing right here. I told it to only go this far, so there should be a plus ... if it was the infinite series. But that's where it comes from.